All right, welcome back, class. I don't even know what day it is anymore, so is it spring break? After spring break? I don't even know. But I know today we're going over 11.5, which actually does involve some math on my last lesson. Interpreting data. Interpreting data. And basically, after you've taken the surveys like you created in the last lesson, now you got to interpret the data from said surveys. So they give you some TV thing. It says 5,000 Americans surveyed. Wow, that's a good aim. Americans surveyed. $780 of them watch some lame TV show. Okay? So, what they want you to do is, this was just a survey, right? There's more than 5,000 people in the United States. So there's, according to the book at this time, in the United States, 105 million households in the United States. Not people, but households. And they want you to estimate how many watch the lame show. So normally when you do a survey, it could be that you actually ask everybody, right? But there are times that you want to take a survey and kind of use that survey to make a generalization for a larger group of people. So in this case, 5,000 people we surveyed, which is a lot of people to survey. And you want to use that information and you want to kind of generalize that conclusion towards the 105 million people, because it's going to be very difficult to survey 105 million people. So you want to try and use your survey and say, this is what I found from my survey, and I think it extends to the rest of the country, for example. So, how many watch the lame show? Okay, well, in my survey, right, 780, oh, yo, Mr. Hill didn't get a calculator, and we know he's bad at math. 780 out of 5,000 watched, right? So if you enter that into a calculator, and you can't see it in this calculator because the screen's not very bright, that's 0.156, which is 15.6%, right? So 15.6% watch according to this survey. So then 15.6% of 105 million, right? So you'd multiply 0.156 times 105 million. And you'll find out that 16,380,000 or 16.38 million people watch. Alright, and so now your generalization is to the country. We interpreted 5,000 people survey and extended it to the rest of the nation. And we found out that about 16.38, 16.4 million people watch this show. So I surveyed 5,000, but we think that our data is good enough to represent more people. Now, in surveys, right, it's probably not exactly that number, right? Probably not, unlikely. So there's a margin of error. There might be more people who actually watched, or there might be less people that watched. So the kind of buffer range is called the margin of error. So, for example, we just said that was, 15.6% is what our survey showed. example, margin of error, you'll generally see it as plus minus, and let's just say 3%. So it could have been 3% less. So that would have been what, 12.6%? Or maybe it was actually a little bit more, 18.6%. So your margin of error is like, this is what the data shows, but it's unlikely that it's 100% correct if I extend it to more people. So the margin, we're not talking about how we come up with the margin of error. There's lots of math calculations to get the margin of error, but you give it and you're like, it might be a little bit less, it might be a little bit more. That's basically the idea behind margin of error. So the classic problem, you're having a election. We got Billy Bob, who according to survey shows that he will get 52% of the votes, right? If you get 50%, you're gonna win. Then you got Big Dog, who, math, dude, shows up, he's gonna have 48%. He's gonna lose, right? Margin of error, let me go back to that young purple pen. Margin of error is plus minus, again, 3%. Okay. The question, can you conclude who wins? Who will win? So, right, it looks like Billy Bob's gonna win over Big Dog, right? However, with the margin of error, if you subtract 3, he's gonna have 49. If you add 3, he could have 55%, right? So he's in the range of 49 to 55. And if you subtract 3 here, Big Dog might only get 45, or he might actually get 51. So, while it looks like there's a larger chance, right, because there's more above 50, right? He only has 50 and 51, but this dude has 50, 51, 52, 53, 54, 55. More numbers above 50 or above, than Big Dog does, right? So it looks like Billy Bob will probably win. However, based on the data and the margin of error, there is a chance that Big Dog will get 51%, and Billy Bob will get 49. So in the data, I can see explicitly 51, 49. Big Dog could still win. If these results are actually true, 52, 48, Billy Bob will win, right? Or if he got the higher end, 55, and Big Dog got 45, Billy Bob also wins. However, there's still the chance that Big Dog gets 51 and Billy Bob gets 49. So you cannot conclude who will win. Okay? Now, there's any of everything in between. It could be like 50-50. It could be 53-47. Anything in those ranges that they give us based on the margin of error are possible results. Okay? So hopefully that's sinking in with you guys. I'm gonna skip that. Y'all can read that example. Whatever. Alright, I'll do number 6. Number 6. Number 6. Favorite subject? Obviously not math. So you survey 100 students. "36 say math is the best It's a big school though. The school has 1,200 students, right? Predict how many would say math is their favorite. Question. Predict how many math nerds say it's their favorite. Okay. So, survey said 36 out of 100 said math is their favorite, which is 0.36 or 36%. And then we want to extend this towards the 1,200 students. So I want 36% of 1,200. So I'm going to do 0.36 times 1,200. And I'm going to get 432. What? Did I do really bad math? Huh? I think the book is way off on that one. The book says 360. I don't think so. Yeah, that's not right. About 432 students would say math is their favorite subject. So, it's at 36%, 36 out of 100, and then you extend that towards 1,200 total students. I know what they did, but they're not doing that good. So, number 8. You've got this book. It says a school student council said it would change the school's colors if 600 sign petition. School gets new colors. School gets new colors. This school uniform color, not digging it. I want a new uniform. All right, you interview a random sample. You survey 50 peeps. Short for people. And 37 sign your petition, right? School has 900 students. 900 total students in the school. Do you get enough votes based on your survey that you're going to be able to do this? So, right, I need 600 signatures. I'm going to go up to probably more than 600 people to get my votes, right, to change the school colors. I'm going to say I'm going to do 50 people and see based on that data, is this really going to work out and I should keep doing this? Or am I really like, ooh, I only got like a few people to sign out of 50. There's no way I'm going to get 600, so I'm going to stop wasting my time there kind of thing, right? So my 37 out of 50, right, that's an easy one, is not about equals 74%. Okay, I'm like, that's pretty good, that's pretty good, that's a nice number. So I did 50 people, right? So if I did 74% of 900, right, that'd be 0.74 times 900. Ooh, not a nice number. Devil number. I get 666. And I see like, that's 66 more people than I need. So even if I get a little bit less, I think I can put in the work and I'll be able to get the result I want. If I found this percentage, I got like 500, I'd be like, it's not looking like even if I keep doing this, I'm gonna get my 600 people because it's obviously not that popular of an idea. However, your data shows that you think you'll be able to do it. So yes, I think we will be able to get the petitions that we need. And that's the idea behind it. Hopefully that made sense. It looks like I had a little bit of a lengthy video. Sorry. Catch you tomorrow.